Good evening, everyone. Welcome to Weaving Algorithms, the threads that bind the Python and the textile communities by Kelsey Vavasour. The stage is yours.
Cool. So, tēnā koutou katoa. Ko ingarangi te whakapaparanga mai, engari no Ototahi Aotearoa au. Ko Kiwi Paikon te kāinga, ko Kelsey toku ingoa. Ngā mihi nui kia koutou katoa. Greetings everyone. My name is Kelsey. What I just opened with is known as a pepeha, or a customary Māori introduction about sharing connections with people and places that are important to yourself. A rough translation is that I am of European descent, but I was born and raised in Christchurch, New Zealand, and Kiwi Paikon is my home. I've been attending for the past couple of years, and it's really been wonderful. I'm a senior software engineer, and I work in the back end of cloud software as a service products using a variety of languages, but I currently spend most of my time in a mix of Python and Node.js. This talk draws from my own experiences and musings, having grown up both as a computer geek and a crafter who ended up getting quite into both programming and knitting in particular, around 8 or 9 years ago now. As someone with ADHD, I find it quite helpful to keep my hands busy while I'm focusing elsewhere, or if my brain's just gone kaput in the evenings. And with knitting, you actually create something physical at the end of it as well. It's a great hobby, but it can be really overwhelming to read patterns when you get started, in the same way that I found programs really overwhelming when I got started with those as well. But as I got more confident with both, I realized that I think about them quite similarly. If you're debugging or trying to figure out what's gone wrong, if you're trying to modify them, or even trying to write your own. But should we really be surprised? When I think about it, I consider knitting patterns basically as programs for your hands. If you follow the instructions correctly, you'll get the same output each time. There really is a lot of shared history. Early computing drew a lot from fiber arts, so we're going to start by exploring this a little bit. So computing has taken a lot of terms from elsewhere in our world, physical items to help us conceptualize what's going on in the digital realm. Some examples we think of more often might be files and folders, desktops and environments, but some examples of terminology that we use have had long lives in sewing and fiber arts prior to their use in computing. When it comes to sewing, interfacing is an extra layer of fabric that's used to help stabilize your material, often in between two outer layers. It can be used for collars and button bands, or in quilts between the decorative front and the backing fabric. There are many examples of this being used in historical garments, particularly in dressmaking and corsetry, although these days we tend to use fusible interfacing, which can just be ironed onto your main fabric rather than sewing them together. The way we use the term in programming is similar, although not quite the same. Ways of connecting different aspects of your program together, sometimes allowing things to work together in ways that they otherwise wouldn't. We also talk about binding variables, assigning things, attaching them to a name. In fiber arts, binding can be a narrow strip of fabric that's attached to an edge to tidy it up, or used to describe how you're securing stitches at the end of your knitting to prevent everything from unraveling. In both cases, it is about attaching things securely to ensure that they're going to behave as you expect. But the term that I find the most interesting to think about is threads. In programming, this is the way of dividing our program execution with individual threads working on separate tasks. But threads are also one of the most important things in fiber arts. You sew with a needle and thread to connect your pieces of fabric together, and fabric is woven from many threads in perpendicular directions, known as the warp and the weft. I sometimes find it quite interesting to think about how much more work used to need to go into every item of clothing that was worn, with fabric being originally hand-woven, and early looms still being complex and laborious machines to use. That is one of the reasons why weaving had a very large amount of influence on early computing. It was a very important task, and it still is, despite the technical advances and globalization disconnecting us from a lot of the work that goes into it. And so, of course, people would make it easier for themselves and others. The more famous example of weaving's influence on computing is the jacquard loom and its punch cards. A loom works by keeping the longer warp threads in tension, with the weft being passed back and forth across each time. Basic weaving, like you may have done in an arts and craft class as a kid, just alternates over and under the whole way across. But weaving pattern fabric was done by having much more complicated combinations, which changes the dominant colour and/or texture, and it would require manually altering which of the warp threads were lifted according to very specific instructions before each pass of the weft, and it had to be done by hand. It would take a very long time to create, even just a few inches of fabric. In the early 1800s, though, French weaver Joseph-Marie Jacquard built on earlier developments by others, such as Jacques de Vaucanson, to create the Jacquard punch card system for automatically controlling the warp. This was an early binary system, as a warp thread can either be lifted or not for each pass of the weft. The pattern would get drawn on paper by the designers, with a cross indicating where the thread should not be lifted. This was translated into punch cards with holes where the X's were not, and these punch cards then got fed into the loom. So if there was a hole, the mechanism would be able to actually lift the thread when the weft thread is passed, leaving the warp thread the one that is dominant in that spot. This existing technology helped inspire some of the thinking of Charles Babbage and Ada Lovelace for the analytical engine, and eventually made its way to being input for early computer systems. But my favourite example of weaving's influence on computing that I didn't know about until more recently is the core rope memory for the Apollo guidance computer. Magnetic cores were used a lot in early memory, although for the read-write memory, one core meant one bit. But with the core rope memory, which was created by physically weaving wires through these tiny magnetic cores, it went through the core for a 1 bit, or bypassed it for a 0. Inhibiting wires were used to control which core was being read at any one time. And with this mechanism, they were able to thread dozens of sensing wires through each core, so while the data was fixed, it didn't take up too much room. This enabled the storage of a lot more data in the tiny amount of space available for the spacecraft, although it could take months to weave a single program. But what about knitting? Why did I bring that up earlier? I personally find it really interesting to learn about where things came from and dive into the why of things to help me actually understand what is going on. I tried to learn programming several times in high school and I actually bounced off it each time due to everybody saying, just throw yourself in the deep end, it'll be fine. But it wasn't until I went back to study a general IT qualification after having my first child that I really actually got my head around it. And that was because the first mandatory programming class actually broke down the structure of a program, and that really made everything actually click for me. And then when I started trying to knit things more complicated than just a scarf, and I wanted to alter the output that I was going to get, I found myself really starting to think about the similarities in the way that I approached both of these things. So, do we have any knitters here at the moment? Cool, we've got a few, that's awesome. So you guys will understand this, but for everyone else, it might seem quite overwhelming and confusing if you just see all of these giant rows of text. This is a fairly famous but simple pattern that's known as a fish and chip vest, which often gets knitted for babies. A friend made one for my oldest son when he was much younger, which is where I first came across it. It's quite a square and stretchy garment, but that's all you need for small babies. But there is a lot of assumed knowledge here, even with some of the extra bits of instruction that it includes. But we can break this down into component pieces, like that class did for me with programs, and things might get quite a bit easier to understand. So, the way I think about it, you actually have a lot of the things that we have in programs in our knitting patterns. There's a lot of basic stitches that are used in pretty much every pattern without extra explanation or instructions. And I look at these as sort of like language keywords and built-in functions. In terms of language keywords, we'll have things like knit and purl, which are your two most basic knitting stitches, with a purl effectively being a backwards knit stitch. as well as casting on, which is creating the stitches at the beginning so you have something to work off of, and casting off, which is another way of saying binding off, which I mentioned before, actually securing all of your stitches at the end so the entire piece isn't going to unravel. There are other more common stitches that may often have a brief explanation at the top of a pattern for general consumption to ensure that they're understood. But for more advanced patterns, this may be skipped over as they expect that you know what you're doing. These are things like yarn overs, which are used to create holes, particularly in lace knitting, decrease and increase stitches, where you want to change the number of stitches you're working with to create shape in the finished product, or ribbing, which is alternating knit and purl stitches in order to create a much stretchier fabric. I look at these as similar to built-in functions of your core language libraries, aspects that are widely documented and understood and provided to everyone who is working with those tools. So these are just some nonsense pattern bits up on these slides, but you can see we're just going to knit 10, purl 10, we're yarning over, knitting 2 together. It's just a basic little thing that you could follow. But what if you want to get a little bit more complicated? Well, you can define a small function at the top of your pattern. So many patterns that I have seen will include the instructions for a more complicated set of stitches written at the top, so it can just be called later on in the pattern by referring to it by name. This allows reuse of your instructions without constantly repeating yourself, and it makes it easier to conceptualize the steps you're going to be taking as you follow the pattern. This is similar to how you may take parts of your code and turn them into a function to make reuse easier, or give it a useful name to make it easier to read later on. I once knitted a pattern you can see here for these gloves that had the definition for this daisy stitch, although they said it looked a bit more like a star for that one. You're knitting several times into one loop in order to create this sort of starburst-like pattern. It would get really complicated to try and read if you're going to have these instructions constantly throughout the whole thing. But it's so much simpler to follow with a named function call instead. But what if we're getting more complicated again? Well, you can include some large functions in your pattern, or sections of it. So when you're making a more complex item, the pattern does get broken down into these sections. If you're knitting a top, this could be the yoke, which is the top part with the neck hole and the shoulders down to your underarms where the sleeves split from the body, as well as the sleeves and the main body. Or if you're knitting a plushie, it might be different sections of the finished item. For this wee dragon I was knitting here, the head was first, then the neck and body, tail, some limbs, and then some spikes to go along the back as well. If you want to change the length of a garment, or the fit in an area, you can look to the instructions specific to that section of the pattern. As well as if you realize that something has gone wrong with your output, being able to identify where the output has differed from your expectations can make it a lot easier to fix. And while with knitting it tends to be human error following the instruction, I have seen patterns with bugs. There are patterns out there that have published errata to correct mistakes that were identified by people who had been trying to follow them and just ran into trouble. And these functions often get called multiple times in a more complex pattern, such as creating 2 sleeves for a sweater, or 2 or more limbs for a plush toy, depending on what you're trying to create. And speaking of repeating yourself, we have a lot of loops in knitting as well, when you're needing to repeat stitches. So loops are incredibly common in patterns, alongside calling your functions multiple times, and there could be many types of break conditions. Often you'll see sections in square brackets like this, which are defined and then repeated across the rest of the row, or a set of multiple rows will be created many times to end up creating the desired outcome. Some of these loops end up involving small offsets at the start of the second row so that you can create a desired look with alternating places of your fancy looking stitches. And sometimes you also use what are known as stitch markers, which you can see one there with the little rainbow loop of thread, which help identify the places where the instructions are going to change or potentially stop repeating. Sometimes you'll have increases in between your stitch markers, so it'll just say, do these stitches, knit to the end when you get to your pattern marker, and then you know it's time to stop. And we'll also have control flow in our patterns. Particularly when knitting garments, if you're trying to size them, it's usually done through what amounts to if statements or case statements. A different stitch or row count will be given for different sizes, which is then up to the reader to follow it correctly. It effectively feels like it translates to, if size X, knit 20 stitches or rows, or if you're looking for size Y, then you'll knit 30. My personal favourite example of taking all of these techniques and using them is when my son really wanted a Minecraft skeleton plushie for his birthday. But those things are really expensive to buy from the store, as some of you might know. And I had the double whammy of being both a poor student and solo parent at the time, so that was way out of budget. So I decided I was going to try and make one for him. But it didn't matter how much I searched. I couldn't actually find a pattern for a Minecraft skeleton plushie. But I could find several for creepers. So I made sure I studied the pattern, saw how it was creating the square, blocky look for the creature, and then modified the various sections and enlarged it a bit so I could get the rather different outcome that I was after. We wanted to keep everything square, but instead of just a head, a body, and 4 stubby little legs, it needed a larger head and a midsection to the body, as well as actually having arms and legs. I'm pretty happy with how it came out. It wasn't perfect, but he really loved it to pieces, quite literally. I didn't come up with a very good way to attach the arms because I wanted them to move, so they are falling off these days, but it still has pride of place in his toy collection, that the giant pile that he sleeps with every night. So there is one other big connection between particularly the Python community and fibre arts that I want to highlight while we're here. And it's the very reason that I'm even standing here talking to you guys today. Both the modern fibre arts communities and the Python community have a wonderful focus on diversity inclusion that I find amazing. These are topics that are incredibly important to me, and to speak out and try and encourage others, as without other people putting that effort in, I would not be here where I am today. And I find it really important to pay it forward now that I've got to the position that I am. I didn't consider any form of IT as a career at first, despite growing up attached to computers, as I couldn't really see myself in the industry. Despite the early history of computing being full of amazing women, the general vibe of IT is that of a fairly male-dominated one. And I also hadn't really figured out how my brain worked at the time and how to work with it and actually achieve the goals I was setting out to. It wasn't until after I'd had my first child and I wanted to get out of hospitality where I'd ended up that I really considered giving it another chance. I went back to study IT and I finally had programming click for me. But as a neurodivergent solo parent, I still found it really hard to get to professional networking events and conferences. The whole process seemed overwhelming and confusing, particularly when they often happened after work, when I needed to get home to make dinner and get them to bed. But then I went to KiwiPyCon for the first time, and I was blown away from the moment I started registering to attend at the efforts they were putting in for everybody. The registration form had all of these questions phrased in a really respectful way with understanding explanations to help ensure that everybody could feel comfortable and be catered for. Asking for your pronouns in a respectful way and your identity, and actually explaining what these questions were for and providing explanations for people who might not understand why they were there. They also had these amazing stickers that were available to indicate how comfortable you actually were with striking conversations up with people and what conversations you might be interested in having. There was the low sensory room available for those who needed it. And as an autistic ADHDer, there are very much times when I appreciate that sort of thing. Just having that quiet space available to go into when you're getting overwhelmed by the world and you need it is honestly amazing. It makes a huge difference to my ability to last throughout the entirety of these events. But one of the big ones was the fact that they had childcare available. As mentioned, as a solo parent, I had to miss out on so many events as it would clash with their needs, or I didn't feel like I could justify organising someone else to watch them in order for me to be able to attend. So seeing that they actually had childcare available and they'd considered the needs of people like me Made me feel like they actually wanted me there and involved and included, and that was just an amazing thing to realize. All of these efforts inspired me to submit a lightning talk, to stand up and say thank you, highlighting why it's an important passion of mine, how much it meant to me, as I know it can be really beneficial to hear that sort of thank you. It was the first time I'd stood up in front of an unknown audience to deliver a short talk, and despite feeling like my intense nerves were incredibly obvious and completely forgetting how I'd intended to end the talk, I was blown away by the response that I received. They even made a wonderful sticker based on one of the lines I said that I've got here on my laptop now, which is, when it comes to diversity and inclusion, this is another one of those places where it's really important to be explicit rather than implicit. I ended up invited back last year to be part of our panel on inclusivity and diversity alongside several others, a couple of whom are here staffing PyCon US today, who helped me understand that it really wasn't just Kiwi PyCon. This is a global Python community thing. So shout out to Lauren and Chris for also being amazing. Speaking there, the way the community accepts and welcomes everybody for who they are helped me gain confidence to consider submitting a longer talk in order to share some of my musings and passions. And so this is my first big conference talk, so thank you everybody who's here in the audience and listening to me. And PyCon US here has been amazing as well. All of the inclusivity efforts here and those made by the Python community in general are honestly so amazing. As mentioned, I appreciate the fact that there is the quiet space up here as well, as it makes a huge difference. The different ribbons that are available for your badges to help inform others about who you are, how you're involved, and what levels of interaction that you are comfortable with. I've ended up attending a couple of open spaces while I'm here, meeting other queer and neurodivergent Pythonistas, and it's been an amazing opportunity both to meet people, but also to hear about the different ways that the Python community has helped and how we can give back to help improve things. I've also really loved seeing all of the different groups in the community that exist here to help promote the participation of underrepresented groups within the larger space, such as PyLadies and the Black Python Devs stall down in the open space. I see many similar efforts within the fibre arts communities as well, both online and within the conventions that they organise. Their conventions might seem quite similar to what we have going on here, often containing a mix of tutorial sessions as well as booths where you can purchase supplies such as yarn and crafting tools. And there's a really big focus on making sure that everybody can feel included, trying to make sure patterns can be size inclusive for larger people as well as your more standard fashion model sort of size that a lot of mainstream pattern companies might try and stick with. Both communities are also full of people who are able to feel comfortable being and expressing their true selves, and it honestly has been wonderful to see so much of that here in Pittsburgh. I want to make sure I say thank you to everybody that cares and that puts effort into making sure as many people as possible actually feel welcome and that they are able to participate. I believe we create a better world by ensuring everyone is supported to have their best outcomes and is able to feel valued and included, no matter what their contributions may be able to be, what they look like, where they come from, or what their background is. We create a better world, and it's important. So, some conclusions. I feel that understanding the links and commonalities you may have with other people, other communities, other hobbies that you might never have considered can really help understanding and appreciating the different perspectives that we all have. This helps with problem solving, with communication and collaboration, which are all really important skills in our fields. Understanding how things work, how we can tease them apart and put them back together again, is a really useful skill when it comes to being a software engineer. And again, if you step outside of your comfort zone, you apply it to other situations or hobbies that you might not have thought about before, it can help you gain new perspectives on what is happening in your code. So can understanding where things came from and how they grew into what we know and love today. Enjoying digging into the background and history of things has definitely helped me when working on trying to debug or untangle a pile of inherited spaghetti code, particularly when the original writer has long since departed. If you can put yourself into that mindset of somebody else, you might be able to understand what exactly they were thinking when they actually wrote that piece of code. And that can help you to understand where things may have gone wrong, or what they were actually trying to accomplish. Also, knitting is fun. It's a really satisfying hobby. Once you get past the inevitably awkward early stages, it can be really easy to pick up and put down when you need to, and you actually get something physical to show for your efforts at the end. You've created something, which, as someone who works primarily in the digital realm, is quite a nice thing to produce on occasion, particularly if you know people who appreciate the care and effort that goes into handmade gifts. So, I hope this talk has been able to give you an interesting new perspective on things, and help to highlight some connections that you might not have been aware that you actually had. Ngā mihi nui, kia pai tō rā. Thank you so much for your time, and have a great day. So, I've tried to leave a little bit of time here for questions if anybody does have any, but I'll also be around if anybody wants to come and talk.
Can you put the original pattern back up? Because I forgot to get a picture of it, and my partner is already cussing me out.
I can get back to that. There it is.
Thank you so much for the talk. I love this Venn diagram of like fiber arts and coding, and I've had so many of the same thoughts when I started learning how to knit. I've spoken to other people around PyCon who also love fiber and love coding. Do you know actually if on, for example, Ravelry, there is any sort of Python community as well?
I don't know, but that would be amazing if we had one. We should make one.
Exactly, okay.
Okay, we should do that.
What's the most complex thing you knitted?
Oh, plushies probably are the most complicated things I've ended up knitting. One that was a lot more complicated than it looked like it was going to be was I actually decided to knit a little COVID plushie a couple of years ago. I probably had far too much fun taking that into the office and throwing it at people and just saying, catch. I had a few people who were fast enough to go, immunized. It was great.
So you said that knitting has control flow and looping, right?
Mm-hmm. Yeah.
So that means it's Turing complete?
That is a good question. I hadn't thought about that.
Also, you could probably make a knitting program that could be never knitted.
Yeah, there definitely is. I have seen tools out there for working with knitting patterns in your code, and I think they're quite interesting to have a look at. The talk from last year around doing embroidery patterns in Python was really quite an interesting one as well. So if you haven't seen that, I'd recommend checking out the recording.
Also, you could probably make like a knit interpreter, so like, could like execute a knit in sequence to generate images.
Yeah, knitting machines are a thing, although crochet machines are not, because that's a lot more complicated in 3D, and it's much harder to convince a machine how to understand that one.
Thanks.
No worries. Cool. Anyone else? Awesome. Okay, thank you very much for your time and attention, everybody. I really appreciate it.